So if you're like me, you have a lot of scraps, leftover sprues and pouring basins, chopped up bits of failed castings. Problem is, as I understand it, is, well, the problem with all aluminum is you're not looking at aluminum. When you look at a piece of aluminum, you're really looking at pure aluminum surrounded by a layer of aluminum oxide. And this oxide forms a film, a chemically inert film around the aluminum. And when we melt it, that film comes loose and breaks up and creates little floating bits of aluminum film that folds upon itself and creates aluminum bifilms, which seems to be a modern focus in casting quality. And so I've been working on a possible way of cleaning out some of the aluminum oxide bifilms before pouring. All right, so I have my crucible cleaned best I can. And to filter the metal, start with a flat pattern, which I test out in paper to make a filter, and then reproduced in 30 mesh stainless steel wire cloth to make a filter at the end that charge with metal and melt, and then slowly pull out, and we should have filtered metal. We'll see.
All right, wire filter. I've got a good zoom on it.
Now here is the filter removed from the crucible just before the pour, as you saw. And a couple things to note. It's hard to tell, but it would not surprise me if there is a little bit of mass loss here. If these, wires are maybe just a little bit thinner. So I'm sure some of the metal from the stainless steel, 316 stainless steel, did dissolve into the aluminum. That's for certain. The question is how much, and how does that affect the final properties of the aluminum. But you can see quite a bit of junk got trapped. I mean, a lot of that is the slag on the surface, but the hope is that down below that there's other bits of biofilms that were trapped by the mesh and